Good evening, everyone. Welcome to 116th video on misconceptions in physics. Okay, my name is Ratankar Rao. I teach physics in an international school in Bangalore, and my hobby is to teach physics using videos. And whatever you are looking now here is about misconceptions. That is, a single concept can be used at two different locations or two different contexts. And as a result of it, students generally make a mistake. And I've tried to identify possibly what types of mistakes they do. And the result is this number of videos. So this is not a coaching for any kind of course. Okay, this will just help you out to clarify your concepts in detail. Thank you. With this brief introduction, let me start today's video. And for the past 6 days, we had been working on the type of problems, what you call it as comparison problems. Okay, let me just locate my pen. It's not writing. Just give me a moment. Let me start with this. Okay, so right, okay. So we had been working on comparison problems. Comparison problems are those problems wherein you have a single parameter which changes in two different contexts, and we are going to find out, okay, how to utilize it. That's what is a comparison problem. Now, towards it level, let us start with this one. So far, we've been looking only at comparing distances. We are not gone beyond that. There are several types of comparisons that one can make. You can compare velocities, compare accelerations, compare angles, compare resistances, compare temperatures. You know what all parameters you have in two different contexts, you can do it. But of this also, okay, there are several scenarios. So most of the problems in physics, okay, so we will be having these kinds of problems. Let us work on it. So ball A is projected with a speed u at an angle of 45 degrees with the horizontal. Now we are talking about a projectile motion. So you take a ball A. Now let me write down the projectile motion here. Take a ball A, you are throwing it like this. Now the ball A undergoes a projectile motion like this. It falls here. Okay. Now this is my ball A. Let me write something. This is ball A. Now it has been projected with an angle of 45 degrees. So this is my initial velocity. Now this is making an angle of 45 degrees. At a distance of u square by g, at a distance of u square by g, where is the distance of u square by g? Somewhere here. What is u square by g? U square by g, I do not know what is that value. Okay, let us do that. Another identical ball B is projected with an angle of 60 degrees. Will they collide? Now what happens? U square by g. Now, when you look at this, this is nothing but, if you look at the range, okay, for people who have already worked on projectile motion, okay, you know what is the formula for range. This is my O, this is my A. OA is nothing but the range. The horizontal displacement of the projectile along the x-axis is nothing but the range, and the vertical displacement along the y-axis, okay, is nothing but the height, maximum height. So remember, we are now talking about the next level, which is nothing but your motion in 2 dimensions. If you are only working on motion in 1 dimension, probably you may not understand this. Okay, this is the next chapter. If you are a 9th or a 10th grade student, you may not get this. But if you are a 11th or a 12th standard student, then definitely you might be understanding what I am teaching here. Okay, now let us look at this. Okay, so there's already a here. I'll do one thing. Let me write this as OP here. OP here. Right. So this is projectile motion. So we know that the range formula is given by u squared sine 2 theta divided by g. This is the formula for range, where u is the initial velocity, theta is the angle 45. So if I substitute this value, I get the answer as u square sine 90 divided by g, which should now be equal to u square by g. Now here also it says at a distance of u square by g, another ball B is projected, which means now u square by g is this distance. U square by g is this distance. U square by g is this distance. So from this point, one more ball is being projected with an angle of 60 degrees. So he's not projected at 45 degrees, but he is projecting at 60 degrees. Like this. Okay, and maybe not even here. Okay, so let me write this as 60 degrees over here. 60 degrees. Then, will they collide? Very simple here, very simple. Will they collide? Now this is the question. Now, will they collide or not is a bigger question. Now, how do we approach? Now, the student, what he did was, he did something like this. Since same initial velocity is used by both the balls. See, he is throwing this one also with the same initial velocity, and you are throwing it from here. From the point where this ball terminated, you throw it here, but only difference is the angle is 60 degrees. Okay, but anyway, he thought, oh, this is u square by g, not u2 by g, u square by g. So it's used by both the balls, and u square by g is the range of the first ball from which the ball b is projected. Okay, and they will definitely collide at the center. This was the reasoning being made. But there's a misconception. Why is this a misconception? Let us understand this. Now, towards it, now, first thing is, if they have to collide, what is that you need? Now, let us say if two balls, I throw from here and I throw from here, two particles, if they have to collide, that means their x velocities, their velocity here, this ball will have an x velocity here, while the y velocity will become 0. Similarly, this ball will have an x velocity here, the same as this velocity, but while y velocity will become 0. Okay, so now this condition should be same. Means what should happen? I can write this as ux comma a should be equal to ux comma b. Okay, so I will just write these values, and then I should also have uy comma a is equal to uy comma b, which should be equal to 0. Okay, they should not be having any y velocity. Now let us see what is uxa, uxb. Now uxa is nothing but u cos 45. U cos 45, right? And what is uya? Uya is nothing but, you see, this is u here. Now this is the positive direction. This is a positive direction. This is a negative direction. Okay, you can have negative direction, doesn't matter. Okay, I'm just looking at the magnitudes. But unfortunately, so here if you look at this should be u cos 60. Now if it is u cos 60, where will it be? Now u cos 60 and u cos 45 are not equal. So definitely they will not collide. Which means that uxa equal to u cos 45, okay, multiplied by a given time, it will be somewhere over here, and this could be at some other distance over here, right? Or maybe it might be somewhere over here. Okay, as a result of this, or it will not be here, it could be somewhere over here, it could be somewhere over here, it could be somewhere over here. Because you know, the angle is much larger over here, 60 degrees, so definitely it would go much larger, and hence they will not collide. And hence you can say the balls will not collide. Okay, so there's not much of mathematics over here. Only thing is you should know, okay, how to logically express this. I hope you understood this problem. And if you have any more doubts, you can always write back to me and I'll be happy to help you out. Thank you, friends, for watching this video. Share and subscribe to my channel for more updates. Thank you.